Ayan. So, our lesson for today is about current and resistance. Ayan. So, class, medyo anuhin ko na lang yung discussion natin and then I will just let you read or browse yung module natin kasi nasa module naman natin ito. Okay, electric current and resistance. So, what is an electric current? So, you know, the application of electric current sa daily lives natin. So, yung current or yung kuryente, tinawag yung sa electric because meron iba-ibang klase ng current. Like yung water current. So, this is subject natin ito ay electric current yung pag-uusapan. So, that means, ang ibig sabihin kasi ng current, something is moving. So, something is moving dito. At ang nag-move sa subject natin, dito sa particular topic natin is yung charges. Okay? So, pag nag-move ang isang charge, we call that a current, particularly electric current. Ayan. So, electric current is the rate of flow of charge through some region of space. So, the SI unit of current is ampere. So, 1 ampere is equal to 1 coulomb per second. And the symbol of electric current is I. Okay? It's not C because C is taken by capacitance at I. Ang I ay ginagamit siya. You think of it as intensity. Okay? So, yung symbol ng current natin is I. Like yung charge, hindi natin siya tinawag na C kung hindi Q for quantity. Ang I naman, hindi rin natin siya yung current naman, hindi natin din kinamit yung C kasi ang ginamit natin is I, or you think of it as intensity. Ayan. So, ang sinasabi ng generally, ang current daw is yung rate of flow ng charge of some region. So, kung rate of flow yan, so that means that is Q over T. Kasi, di ba, Q is in charge natin, which is in coulombs, and T is in seconds. So, coulombs per second, and coulombs per second is 1 ampere. Okay, so what is the average electric current? So, if we have, ayan, so meron daw particular area dito, and then charges are moving to in this direction. So, marami tayong charge. So, yung current natin is flowing in this direction. Okay, kagaya lang ito ng average velocity natin and acceleration. Pag ang average current yung hinahanap, so that's equal to the change in the total charge over the total time. So that's equal to Q final minus Q initial over T final minus T initial. So that is the total number of charges moving at a particular area over the total time. So in total time na nag-move yung mga total charge na yun. So that is the average current. Ayan. So, ito yung formula natin. Ay, ba't nandito siya? Ba't nandito siya sa baba? Okay, so average current is equal to delta Q over delta T. Still, ang unit natin is coulombs per second and that's in ampere. Okay, so imagine nyo, nag-move yung mga charges natin yan sa wire. Okay, sa wire. So, syempre yung wire natin is cylindrical in shape. So, meron siyang cross-sectional area. So, in total charge na nag-move dun sa wire natin passing through a cross-sectional area over the total time na nag-move or pumasok doon sa cross-sectional area na yon, that will give us the average current. Okay, so yung instantaneous din naman, so yung instantaneous current natin ay, ayan, so yung current natin, so meron is equal siya, na instantaneous is yung average current as the limit of delta T approaches 0. Or, yung current natin na instantaneous is equal to the first derivative of our charge. Yeah. So, yung charge natin, yung given siya ng equation with respect to time, and then get the first derivative of the equation of the charge, you will get the instantaneous current. Okay, may question ba? Ay, class, if you have some questions, you don't hesitate to write in the public chat or you speak in the microphone. Okay? Okay. So, ngayon, ano ang direction ng current? Ayan, direction of current. The charged particle passing to the surface could be positive, negative, or both. So, ayan, yung sinasabi ko before, yung conventional at saka yung electron flow. So, sa conventional kasi, it is a sign that the current to the current the same direction as the flow of positive charges. So, kung ang positive charges natin ng electron, kung anong direction ng mga electron, yun yung magiging direction ng current natin. So it is ordinary conductor, the direction of current flow is opposite the direction of the flow of electrons. Okay, so ito yung sinasabi kong difference ng conventional at saka ng electron flow. In reality kasi, ang nag-move talaga ay yung mga electron. So that means yung mga electron, okay, if we have a battery, and okay, so taas meron tayong wire, di ba ito yung positive, ito yung negative. In electron flow, ang motion is yung mga negative. So kung yung mga negative, okay, ito yung positive. Siyempre, ang motion nila is from negative going to the positive. Kasi kung electron niya, negative ito, negative, negative, the force is repulsive. So that's why it's moving down. Negative to positive, so siyempre, attractive yung force. Kaya motion is pa ganyan. Okay? Kaya lang, ang conventional flow natin, ang nagmo-move is yung mga positive charge. Okay? So that means ang motion is positive, positive, that's repulsive, and then positive, negative, it's attractive. Kaya, ganun yung motion natin. Okay? Ito yung sinasabi ko before, na ang sa engineering ang ginagamit natin is yung conventional flow, not the actual flow or the electron flow. Pero syempre, in reality, yung mga nagmumove ay yung mga negative charges, yung mga electron, hindi naman yung mga proton. But, of course, ang susundan natin ay yung conventional flow. Ayan. It is common to refer to any moving charge as a charge carrier. Charge carrier. So, mga moving charge natin, ayun yung mga charge carrier natin. But, ang susundan lagi natin ngayon ay yung positive charges. So, sa conventional flow tayo, hindi tayo sa electron flow. Okay, so drift, current, and drift speed. Okay, charge particles move through a cylindrical conductor of cross-sectional area. So, yung mga charge particle natin, so nagmo-move sila. Let's say this is a conductor. So, N is the number of mobile charge carriers per volume. So, NA delta X is the total number of charge carriers in the segment. Okay, ano ba? Ang N daw kasi, ang N is the number of charge carriers. So sila yung mga nagdadala ng charge. Okay, so kung gusto nating malaman ilan ang charge carriers dito sa ating dito sa ating cylindrical shape na conductor, syempre yung N, i-multiply natin siya ng volume. So yung volume, pero volume is equal to, syempre yung A times delta X. So yung A, volume ng cylinder, yung area ng base, tapos yung height niya. Kaya yung number of total charge carriers is N times A times delta X. Ayan. Okay? So yun yung mga total charge na nandito sa ating conductor na volume na to. Okay? And then the total charge is the number of carriers times, ayan. So yun yan. So yung total charge natin, okay, total charge is equal to yung number of charge carriers times yung charge. So that's equal to NA delta X times Q. Okay? Assume that this moves with the velocity parallel to the axis of the cylinder such that they experience a displacement of delta X. So therefore, if the speed of the charges is equal to delta X over delta T, ayan, ano yung ating delta X? Okay, so delta X natin is VD times delta T. Okay, VD times delta T. Okay? Ngayon, ito, isa-substitute natin siya dito. So that means the total charge is equal to NA times VD delta T times Q. At kung i-divide natin to ng delta T, so that's equal to delta Q over delta T is equal to NA VD times Q. But what is delta Q over delta T? Di ba yun yung current natin? Ayan. So that's why current is also equal to the total number of charges times A times V, the drift speed, times Q. So that's VD. Okay, so VD is the drift speed. Ayan. So VD is the drift speed. Sometimes they call it the drift velocity. Ayan. Okay, so that is the drift speed. Okay, class. Ang drift speed is a very, 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 very slow motion ng charges. Okay? It's a very slow motion of charges. So, huwag niyo kakalimutan ang formula natin. So, ito yung formula ng current, total charges, and yan. Okay? The average speed is called the drift speed. So, ito yung average speed ng mga charges natin dito sa conductor natin. We call it the drift speed. Okay? So, we call the average speed of the charges doon sa conductor natin na drift speed. Okay. So, when these charges are in the conductor, yung motion nila is nandito. So, tingnan nyo. Okay? So, syempre, nasa loob sila ng conductor. So, yung motion ng mga charges natin is in random. So, in random yung motion nila. So, halimbawa, ito yung conductor natin. So, yung motion nila is ganyan. Kaya, masyadong mabagal yung ating drift speed. Tama ba? So, masyadong mabagal yung drift speed or yung average speed ng mga charges natin kasi they are moving in random. At the same time, masyado kasi silang madami. So, syempre, hindi lang naman iisa yan. So, madaming charges na yan. So, nagtutulakan sila dito sa loob ng conductor natin. Kaya medyo mabagal yung ating drift speed. Okay? And that is okay. Kaya mabagal yung ating drift speed. That's because of that. Okay? In the presence of the field, in spite of all collisions, the charge carriers slowly move along the conductor with the drift velocity. So this forces on this field conduction in the wire. So this forces causes the electrons to move in the wire and create a current. Okay, so basta ang definition ng current, when charges are moving, we call that already current. At ang drift speed natin ay masyadong mabagal. Kaya ang question class ay, bakit? Halimbawa, meron akong switch. Kung ang drift speed or motion ng charges natin ay mabagal, bakit pag sinindihan natin yung ilaw dun sa switch, automatic siyang sumisindi? But we're saying na mabagal siya. Mabagal sila, pero bakit automatic na pag tinurn on natin yung switch, iilaw agad? Why? Kasi naka-chain po sila. Pwede bang paki-explain mo na further, Jim? Ako na lang ba sasagot? Sige. Manintayin natin si Jim tsaka si Daniel pa. Parang sumasagot. And then, kasi, class, di ba wire yan? Ano yung composition ng mga wires natin? So, di ba, in terms of, if we will describe the molecules, di ba, dikit-dikit sila? So, that means, hindi mo naman hihintayin yung charge dito para pumunta doon para sindihan niya yung ilaw. Kasi, meron nang nakaabang pa dito. So, dito pa lang sa dulo ng wire natin, malapit doon sa ilaw natin, may charges na. Ang kailangan lang ay may magtutulak sa kanya para pumunta doon sa ilaw natin. So once na-fill natin kasi dito, so yung mga nandito sa tabi ng switch, itutulak lang nila yung nasa harap nila. Sabi nga ni Jim kanina, chain sila. So probably, yun yung gusto niya sabihin. Okay? Na marami nang nasa harap niya. Okay? At konting tulak lang dito, madami nang matutulak doon sa dito sa coir na to at automatic yung charges pupunta na doon sa ilaw. Okay, kahit mabagal yan, talagang ang halimbawa yung particular charge dito, talagang magtatagal para makapunta siya doon. Pero hindi naman niya kailangan siya muna para umilaw yon kasi madami naman charge dito sa wire natin na mauna sa kanya. Okay? It will take, do you believe na it will take years? Would you believe na ang isang charge could take like days or years para makapunta siya doon sa ilaw mismo? Yung particular charge, ha? Yung particular charge yung pinag-uusapan natin. Let's say yung charge natin nandito. Para makapunta siya doon, it will take a lot of time. So, kailangan talaga yung nauuna sa kanya. Yun yung mga magbibigay ng ilaw dun sa ilaw natin. Okay? Okay, so ito yung sinasabi ko. Okay, so electrons are already in the wire. So, kailangan lang ng konting response dun sa likod nila para mag-move na yung nasa harapan. So, the battery does not supply the electrons. It only establishes the electric field. Okay? It can only establishes the electric field. So, my class, I skip that topic. I will just give you a link on electric field. Okay? Okay, ang charge, ang battery ay hindi siya nagsusupply ng charges. Nagsusupply lang siya ng field. At yung field yung nagpapamove dun sa charges natin. So, dahil, yes, Daniel, what's the question? Okay. Ayun. So the battery goes not supply the electrons. It only establishes the field. Okay. Assume a copper wire with one, for example tayo, electron contributed. The drift velocity of a 12 gauge copper wire carrying a current of 10 amperes is 2.23 times 10 to the negative 4 meters per second. Imagine, na-imagine nyo ba yung drift speed? Ayan. So yung mga drift speed natin ay mga times 10 to the negative sila. O ganyan sila kabagal. Okay? Okay, so meron ba tayong question sa current? Okay, so review lang natin. Ang current natin, general formula, Q over T. Yung average current natin is delta Q over delta T. And then yung ating instantaneous current is dQ over dt. At current din natin in terms of number of charges is NA dQ. Wherein ang drift speed natin is also equal to the length of the conductor times the total time. So this is the length of the conductor over the total time. So that's the drift speed. Okay? Okay, now let's go to current density. So yung current density naman, ang symbol niya ay J. Hindi ko alam bakit J. Okay, the current density of a conductor. Ayan. So ang current density natin na J ay equal siya dun sa current over area. So yung area na yan, ay dyan yung dumadaan yung current natin. So kung meron tayong wire, okay, ba meron tayong wire, ayan. And then yung cross-sectional area ng wire, and then charges are moving in this direction. So that means meron tayong current. So therefore, yung J dito ay equals to yung current over yung cross-sectional area. So that's why the unit is ampere per meter squared. Okay? So the current density is the direction of the positive charge carriers. So yan yung ating current density. Okay, kailangan kasi natin yan later. Okay. Next is the conductivity. So, conductivity ay isa siyang property ng mga objects. Okay, so property siya ng matter which allows the flow of charges doon sa kanya. Okay, class. Kaya alam yung sinasabi nila, ang flow of current daw is redundant. Parang yung traffic daw. Naniniwala ba kayo? Redundant daw yon. Or parang pag sinabi mong ATM machine is also redundant or mali daw. Hindi mo na pwedeng sabihin the ATM machine. Bakit? Bakit mali ang ATM machine? Kasi yung ATM mismo, may machine na. Pag sinabi mo ATM, yung M doon, machine na. Tapos, dodoblin mo pa ng machine. Kaya yun daw sa pagsabi rin ng flow of current, parang redundant din daw. Kasi ang current ay flow na siya ng charges. So parang sasabihin mo daw, flow of charges. Parang yung traffic, flow of traffic, daloy ng traffic ko. Lagi ko naririnig yan eh, daloy ng traffic ko. Parang mali daw yon kasi ang traffic daw is flow of sasakyan na. Flow of vehicles na daw yung traffic. At sasabihin mo pang flow of vehicles. Eh, yung traffic daw mismo is flow of vehicles na. Okay, redundant daw. So, parang hindi, maging aware lang kayo dun sa, sa English ng mga yan. Okay? Yung conductivity is property siya ng isang material, okay, na ang symbol natin is yung sigma. Yan. Okay, so it means the material allows the flow of charges sa kanya. So mostly, mataas ang conductivity ng mga metals natin or yung mga conductors. So ang symbol natin ay yan. So this is the constant of proportionality or the conductivity. Ayan. The current density and the electric field are established in a conductor whenever a potential difference is maintained across a conductor. Pag sinabi nating potential difference, class, that is what we call voltage. Okay, voltage is potential difference. A difference in potential. Potential difference. So that's our voltage. Ayan. So for some materials, the current density is directly proportional to the field. So the constant of proportionality is, ayan. So sinasabi, ang J daw is directly proportional to the electric field. At yung constant of proportionality is the conductivity. So that's why current density is equal to conductivity times the electric field. Minsan may messages Joe. Yan. Para hindi mo makalimutan, tawagin natin siyang Joe. And that's a relation of charge density to electric field. Okay, kasi papunta na tayo sa Ohm's law. Okay? So bakit nauna natin yung conductivity? Kasi by definition ni Ohm sa kanyang law, yung Ohm's law, si state niya daw, for many materials, the ratio of the current density to the field is a constant sigma that is independent of the field producing current. Okay, ang sabi daw, ang definition daw ng Ohm's law is that the conductivity is equal to J over E, or the current density over the electric field. Kaya mathematically, yan yun. So, most metals obey Ohm's law. So, yun yung pinaka-definition ng Ohm's law. That the conductivity is equal to the current density over the electric field. Okay, Ohm's law is not a fundamental law of nature, and it's an empirical relationship valid only for certain materials because for some, it is not valid. But mostly for metals, okay, it's valid. Ayan, yung Ohm's law. Yung relation ng conductivity to current density and the electric field. So, ang sumulat ng Ohm's law ay si George Simon Ohm. Ayan, isa siyang German physicist. At diniscover niya yung proportionalities, yan, known as the Ohm's law. Okay? Ngayon, we have what we call yung resistance. Okay. Magdi-derive ba ako? Sandali. Sige, mamaya ako nagdi-derive. Okay, ano naman yung resistance? Okay? Kung meron tayong conductivity or conductance, meron din tayong resistance. Ito yung opposite or reciprocal ng conductivity. or conductance. Kung yung conductance, sina-allow niya yung charges para mag-flow, yung resistance, nire-resist niya. Binablock niya yung pag-flow ng charges. So in a conductor, the voltage applied across the ends of the conductor is proportional to the current and the conductor. So that the proportionality of current is called the resistance. So resistance is equal to V over I, or the voltage or the potential difference over the current. Pero kung i-cross multiply natin, ang voltage natin or potential difference is equal to current times the resistance. Okay? Ang SI unit ng resistance is ohms. Okay? And that's equal to 1 ohm is equal to 1 volt per ampere. So resistance is in a circuit arises due to collision between the electrons carrying the current, which leads with the fixed atoms inside the conductor. So yan yung ating resistance. Okay, so that's the relationship of voltage to current. Or kung i-cross multiply natin itong relationship na to, V is equal to IR. Pero pag pinag-uusapan ng Ohm's law, lagi nila itong formula yung naiisip. Tama ba? Nag-Ohm's law ba kayo sa high school? Sa high school hindi. Sa high school hindi. Sa physics lab lang. Oh, okay. Ayan. So V is equal to IR. Okay, mamaya ako na sasabihin bakit yan na yung laging naiisip pag Ohm's law. Okay. Okay, next yung mga resistors. Ito lang yung tawag sa mga resistors, yung tawag sa mga ganyan. I'm not sure kung nakita niyo to sa laboratory ninyo. Ayan, so ito yung mga drawings ng mga resistors natin. So merong mga resistance yan in ohms na ginagamit para bawasan yung current or yung flow of charges ay malimitahan. Okay, so mga resistors yung mga ginagamit. So yun yung resistors, yung mga elements, circuit elements na merong resistance. Okay, meron tayong mga color coding para makuha yung value ng resistance, pero hindi na natin to i-explain ng madami. Okay? So, next is yung resistivity. Okay, so parang ito ang, yan, sabi dito, this is the inverse of conductivity. In is resistivity. Ang resistivity natin yung rho, so that's equal to 1 over the conductivity. So that's the reciprocal of conductivity. So kung mataas yung conductivity niya, ibig sabihin, mababa yung resistance niya. Or vice versa, kung mababa yung resistivity niya, ibig sabihin, mataas yung kanyang conductivity. Okay, so meron tayong mga listahan. I don't think nakikita ninyo. Malabo yan. Malabo ba sa drawing ko? Ay sa paper ko? Okay, i-review ko na lang. So, ayan. So, ang resistivity is SI unit niya is ohm meter, and then yung resistance natin is related to resistivity. Ayan. Yung resistivity kasi ay property ng isang material, which is nire-resist niya nga yung flow of charges. Okay? So, merong relation yung resistance sa resistivity. Na yung resistance is equal to rho L over A. Ayan. So, rho L over A. So, ano yung L? So, ito yung length ng conductor. Yung A is yung cross-sectional area. So, this is in meter and this is in meter squared. At yung rho natin is ohm meter. So, that is the resistivity of the object. So, yung resistance ng isang wire or isang conductor ay pwede natin makuha through its resistivity times the length over the cross-sectional area. Ngayon, paano mo patataasin yung resistivity? Para tumaas yung resistivity, kailangan syempre depende yan sa material and then depende rin siya sa length. Okay? Okay, mataas. Kung maliit yung cross-sectional area, mataas din yung resistivity. Kaya hindi naman natin gusto yung mataas yung resistivity, lalo na sa conductor. So mas maganda is maliit yung resistivity. So isang way para palitin mo yung resistivity is lakihan mo yung cross-sectional area. Okay? Meron din kasing disadvantage kung lalakin mo yung cross-sectional area. Siyempre, bibigat yung conductor. So, kahit gusto mong mababa yung resistivity, let's say doon sa mga transmission lines natin sa poste, hindi naman pwedeng para mabawasan mo lang yung resistivity, lakihan mo yung conductor. Hindi naman yata practical din naman yun. So, binabawi na lang nila sa ibang bagay. Okay? So, isang paraan is yung i-change, palitan mo yung type of material. So, alimbawa dito, okay, class, ano ang material na tinatawag na best conductor? Kasi, ang resistivity opposite niya yung inverse ng conductivity. So, ibig sabihin, kung mataas yung resistivity dito, mababa yung kanyang conductivity. Or vice versa. Kung mababa yung kanyang resistivity, mataas yung kanyang conductivity. So, ano ba yung tinatawag nilang best conductor? So, gold, silver, copper, aluminum. Yun yung pinaka-best kasi yun yung pinaka-common. Copper, aluminum, silver, or gold. Okay. Ang copper kasi is common at saka mura kasi siya. Abundant kasi siya. Pero kung best, kung conductivity ang pag-uusapan, hindi yun yung best, hindi yun yung pinaka-mataas na conductivity. Okay, minsan sinasabi nila it's gold. Actually, it's not gold. It is silver. Yeah, silver is the best. At susunod yung gold, tapos yung copper, and then yung aluminum. Ayan, tingnan niyo yung resistivity nila. So yung resistivity ng silver is 1.59, wherein gold is 2.44. Ang susunod pala yung copper. But of course, hindi mo naman pwedeng gamitin yung silver. Siyempre, alam mo naman. Alam niyo yung mangyayari. Ayan. Okay, so nandito yung mga listahan ng resistivity. Ayan. Para kunin niyo yung conductivity, yat niyo lang yung reciprocal. Ayan. So meron tayong coefficient dito. Temperature coefficient. Okay, at huwag yung kakalimutan yung values na 20 degrees. Ayan. So these are true at 20 degrees. So yung mga values na to are only true at 20 degrees Celsius. Okay, 20 degrees Celsius. Ayan. Okay, so let me go back to Ohm's law. Okay, ang sinasabi natin kanina sa Ohm's law, ay diderive ko lang class, no? So, ang Ohm's law, ang sabi diba sa Ohm's law ay J is equal to density times the electric field. Ayan. But what is the current density? Current density is I over A. Okay, so that's equal to, ano ang ating conductivity? So that's 1 over resistivity. Yung electric field, okay, ang potential difference has something to do with the electric field times the distance. Kasi kung meron tayong electric field and then meron tayong dalawang point, ito yung ating potential difference na V. Okay, so ito yung magnitude ng electric field and then yung distance between the 2 points. Kaya V is equal to ED. So kung yan yon, so E then is equal to V over D. So substitute natin siya dito times V over D. V over D. Okay? Kung i-cross multiply natin lahat, so therefore V is equal to I times density times D over A. Ayan. Pero yung D natin, pwede nating sabihin siya na length of conductor. So therefore, V is equal to I times then resistivity times the length over A. But this one is, diba ito yung ating resistance. That's equal to rho L over A. So therefore, V is also the same as IR. Ayan. So dyan na-derive yung V is equal to IR. Okay, kaya yung Ohm's law, na ano talagang Ohm's law, based sa statement ni Ohm, can be written as this one. Pero kaya ito na yung pinaka-ginagamit nating relationship for Ohm's law. Okay? Okay. So, next one is yung resistance and resistivity. So, may relation yung resistance sa resistivity. Alam naman natin na meron tayong formula na R is equal to rho L over A. Siyempre, kung tumataas yung resistance, tumataas din yung, kung tumataas yung resistivity, tataas din yung resistance. Kaya, directly proportional yung resistance at saka yung resistivity. So, directly proportional yung resistance sa resistivity. So, next, ano naman yung relation nila sa temperature? So, class, so habang umiinit yung conductor natin, no, tumataas yung kanyang temperature, yung resistance niya at resistivity ay nagbabago din. Kaya, ayan, sabay-sabay silang nagbabago. Kung tataas yung temperature ng conductor, yung resistivity niya tataas, at the same time, tataas din yung kanyang resistance. Kasi kung tumaas yung resistivity based on the formula, tataas din naman yung resistance. Okay? Kaya kung gusto natin kunin ang resistivity at a particular temperature, so ito yung formula natin. That resistivity is equal to the initial resistivity times 1 plus alpha times the change in temperature. Okay, yung temperature nito at saka to, pareho sila. And then yung temperature nito at saka to, dapat related sila. Ayan. So, saan natin makuha yung alpha? So, yung alpha natin ay nandun sa table kanina. So, nandito yung alpha natin. Okay, dito natin kukunin yung values ng alpha. So, nandito yung mga materials, common materials natin with resistivities and temperature coefficient. Because alpha is the temperature coefficient at ang unit niya ay degree Celsius raised to -1. Okay, so dyan natin kukunin yung values ng alpha. Okay, so that is the relation of resistivity to temperature. Okay, so meron din directly relation ang temperature sa resistance. Okay, so ito na may magiging formula. Actually, they are just the same. So instead na R at alpha, papalitan mo lang yung resistivity ng resistance. So we'll be using the same alpha. Ayan. So imbis na resistivity, resistance lang. So, pareho lang naman sila halos ng formula nung resistivity natin. Halos pareho lang naman sila. So papalitan nyo lang yung resistivity ng R or yung rho ng R. And then we will be using the same alpha na makikita dito sa table 27.2. Okay? May question? Ayan. So, ididiretso na natin. Okay? Ididiretso na natin na pumunta na tayo sa electric power. So, power. Okay? So, ang power in general is equal to it's equal to energy, okay, di ba, and work over time. Okay, so ang unit ng work natin is joules per second, and that's equal to watts. Ayan. So 1 watt is equal to 1 joule per second. Okay? Dito naman ay ano ba na? Paano ba? Didiretso ko na lang ba? O sige, yung power natin in terms of Ohm's law is equal to IV. Okay? But because of V is equal to IR, pwede nating i-substitute yon. So that means ang power can be also written as I squared R, or power can also be V squared over R. So tatlo ang formula natin ng power. Ayan, at ang power, syempre, it's watts pa rin. Okay, paano siya naging joules per second? Okay, paano siya naging joules per second? Ang unit ng IVI, ampere, and then volts. Ayan. Ang ampere ay coulombs per second, at ang volts is joules per coulomb. Ayan, joules per coulomb. So cancel yon. Kaya siya naging joules per second, which is also power. Okay, so power is in watts. Okay, do you have any question? Oh, may question. Okay. Ang mga ang current ba ay scalar or vector? Ang current ba ay scalar or a vector quantity? Okay, sorry, na-late yung poll. Okay. Actually, parang, okay, nakakalito kasi siya because of merong kasing direction yung may direction kasi yung current. Tama ba ako? May direction kasi yung current. Pero, ang direction kasi, para tawagin mo siyang vector, at any point in time, dapat, or any point in the path, dapat, yung direction ng vector quantity ay pare-pareho. Dapat pare-pareho yung direction niya at any point in time. Doon medyo bumabagsak yung current. Kahit meron siyang nasasabing direction, hindi siya isang vector quantity. Isa siyang scalar quantity. Okay? Isa pa. Dapat, pag vector quantity siya, pag nag-add ka ng mga current, dapat susundan mo yung vector addition. Kailangan mong i-consider yung direction. So, halimbawa, meron akong wire, may current dito, let's say 1 ampere, tapos may current dito na 2 amperes. Ano yung current dito? Di ba 3 amperes? Ang sinusundan mo ay algebraic sum. Hindi mo naman kinoconsider yung direction. Kaya, hindi siya pwedeng tawaging vector quantity. Isa siyang scalar quantity. Okay? Sige. So, let's have our example. Kung wala na kayong question. Sandali lang. Okay, let's solve this example. So what is the resistance of a 1,000 meter of a 4 millimeter diameter copper wire? If the resistivity of copper is 1.7 times 10 raised to negative 8 ohms, ohm meter. Okay, so what's our formula? So resistivity is, resistance, is equal to rho L over A. So we're given the, ito, yung length natin ay 1,000 meters. Resistivity is 1.7 times 10 raised to negative 8 ohm meter. And then yung diameter natin ay 4 millimeters. Ayan. So, ang R natin ay, so since diameter yan, so it means a circular. So, that's equal to 1.7 times 10 raised to negative 8 ohm meter times 1,000 meters all over 4 over pi, baliktad, pi over 4 times 4 mm times, for 1 meter, we have 1,000 millimeter squared. Cancel. Okay, so what is what's the resistance? One point 35 ohms. Tama ba ako? 1.35 ohms. Hindi, baka mali ako ng, baka mali ako ng compute. 1.35. Okay? Tama ba? Okay? Okay, so let's have another one. Ayan. So a rod of 2 meter length and a square cross section is made of material with the resistivity of 6 times 10 raised to negative 8 ohm meter. If the potential difference is 0.5 volts, is placed across the ends of the rod, at what rate is heat generated in the rod? So, di ba, ang heat is an energy. Okay? Heat is energy. And then yung rate means it's energy over time. So that means that's equal to power. Ayan. So ano ba yung mga given natin? So we're given the length of 2 meters, the square area na 2 mm by 2 meter, square kasi, and then the resistivity is 6 times 10 raised to negative 8 ohm meter, and then yung voltage natin is 0.5 volts. Okay, so we're looking for power. So ito ay related sa resistance. So that means yung isang formula ng power is that is V squared over R. So kunin muna natin ang R. So what is the value of R? So R is rho L over A. So that's equal to 6 times 10 raised to negative 8 times 2 all over, okay, 2 by 2 meters. So that's a 2 millimeter by 2 millimeter times, for every meter, merong 1,000 millimeter. Since dalawa sila, square natin. So what is the resistance? Parang lakas ng ulan. .03 ohms. Ayan. So therefore, Power is zero point 0.5 squared over 0.03. What's the power? Okay, 8.33 watts. Okay, so the answer is 8.33 watts. Yes, Daniel. Um, I think that's for current. Okay. Okay, next, let's proceed to another example. Ayan. So the electron density in copper is 8.49 times 10 to the 28 electrons per cubic meter. The electron charge is ayan, so 1.6 times 10 to the negative 19 coulombs. When a one current, like 1 ampere current, is present in a copper wire with a 0.42 cross-sectional uh, cm squared cross-section, the electron drift the electron drift velocity in meters per second with the direction defined relative to the current is. Okay. So we are given that the electron density, okay, yung electron density natin ay 8, yung N natin ay equal to 8.49 times 10 to the 28 electrons per cubic meter. Okay, the electron charge, yung charge natin ay equal siya sa 1.6 times 10 raised to negative 19 coulomb. And the current is given as 1 ampere. And the cross-sectional area is zero point 0.4 dm squared. So we are to find the drift speed. Right? So we are to find the drift speed. Okay, so kung babalik tayo dun sa formula natin ng drift speed. So nandito siya. Ayan. So nandito siya. So tingin ko nandito tayo na. Ayan. So ito yung gagamitin nating formula. So meron tayong N, A, Q, and I. Q and I. So current is equal to NA BDQ. So that means the drift speed is I all over NAQ. And that is 1 ampere all over. N is 8.49 49 times 10 to the 28 electrons per cubic meter times area is 0.4 cm squared, but we need to convert that into 1 meter per 100 cm squared. And then yung charge natin ay 1.6 times 10 raised to negative 19. So yung absolute value ko na lang to. Okay, so what is our drift speed? It is 1.84 times 10 raised to negative 6 meters per second. Okay, class, we are, yeah. So 1.84 times 10 raised to negative 6 meters per second. So if we will follow the direction of the electric, the electrons, it should be negative. Okay. Dali, wait. Ano ba tanong? Ano ba tinatanong? Ang tinatanong ay, okay, sorry, ang tinatanong ay velocity pala. So we need to have the direction. Okay, so it should be negative. Ayan. Kung speed yan, the answer would be absolute value. Kasi anyway, velocity pala yung tinatanong, so not the speed. So the answer will be, it's not absolute value. So it should be negative 1.84. Okay. Okay, so let's have the next one. So a current of 5 amperes exists in a 10 ohm resistor for 4 minutes. How many coulombs and electrons pass through any cross section of the resistor in this time? Okay. Ang given natin, current is equal to 5 amperes and then resistance is 10 ohms and then the time is equal to 4 minutes. Okay? Tinatanong ano yung charge. So letter A, what's the charge? And B, what's the number of electrons or N? Okay, so formula natin relating Q to I and this is I is equal to Q over T. So Q is equal to IT. So that's equal to 5 amperes times 4 minutes, but that should be in seconds. So that is for 1 minute we have 60 seconds. So that the total charge is tama ba ako? 5 times 60 times 4. 120. Sorry. 1,200 columns. Tama ba yung 5 times 4 times 60? Because ampere is coulombs per second, we can cancel yung second sa baba. Ayan. So, magiging na lang siyang coulombs. So, 5 times 4 times 16. So, a total of 1,200 charges move ay coulombs ang dumaan doon sa area na yon for 4 minutes. Okay. Next, letter B. How about the number of how many electrons yung nag-pass? Diba ang Q natin, total charge, is equal to 1,200 coulombs. Okay, multiply. For every electron, meron siyang charge na 1.6 times 10 raised to negative 19 coulombs. Answer. So, how many electrons? So, divided by 1.6, 19. So, 7.5 times 10 raised to 21 electrons. Tama ba ako? 2 divided by 1.6 raised to negative 19. 7.5 times 10 to the 21 electrons. Hindi ko na sinama yung negative kasi we're talking of numbers. Ilang electron yung dumaan. Okay? So, a wire of nichrome ayan, is 1 meter long and 1 millimeter squared in cross-sectional area. If it carries a current of 4 amperes when a voltage of 2 volts is applied between its ends, calculate the conductivity of nichrome. Okay, so remember, conductivity is equal to 1 over resistivity. So we do not have any formula on conductivity. So pag nakuha natin resistivity, yan, pwede nating i-substitute dyan to get the conductivity of nichrome. Can you solve this? Okay. Okay, class. Kung ang resistivity, okay, so quantity of charge that has passed through a surface area of 2 centimeters squared varies with time according to the equation. So our equation is Q is equal to 2t cubed minus 3t squared plus 3t minus 5. Okay, what is the average current from 2 to 4 seconds? So average current is equal to delta Q over delta T. So that's equal to Q final minus Q initial over T final minus T initial. Ayan. Pero ano yung ating Q initial? So Q initial is equal to 2 times ang initial natin ay 2 cube minus 3 times 2 squared plus 3 times 2 minus 5. At yung Q final natin ay 2 times 4 cube minus 3 times 4 squared plus 3 times 4 minus 5. Ayan. So, kung nyo lang yung value niyan, 5 column. Okay, 87 column. So that's equal to 87 minus 5 over 4 minus 2. Okay, 41 ampere. Ayan. So the average um, current is 41 ampere. So that's letter A. For letter B, what's the current at 2 seconds? So current means that's instantaneous. So I is equal to dq over dt. So get the first derivative. So that's 60 squared minus 60 plus 3. And then you just substitute 2, 2. So that's 6 times 2 squared minus 6 times 2 plus 3. It's 15 amperes. Okay, letter C, what is the current density? So current density is I over A. So at 2 seconds, ito yung current natin. So that's 15 amperes over, okay, so the area is 2 centimeters squared. So 2 cm squared times 1 meter over 100 cm squared. So the answer is okay, 75,000 amperes per meter squared. So that's those are our answers. Okay.